In our study of differential calculus, we learned about various techniques in finding the derivative of many functions. One of these techniques that we have learned is the product rule, in which the derivative of an expression in a product f of x times g of x can be further expressed in the variables u and v, and can be equated into u times the derivative of v plus v times the derivative of u. So that is the product rule of differentiation. However, in integral calculus, we have something that is called integration by parts, which is basically the product rule of integration. And the equation for that is the integral of u dv is equal to u times v minus the integral of v times the derivative of u. So, to put that equation into use, we have an example right here, which is the integral of ln x dx. Okay? So, given this expression, we have to set our parameters. Okay? So, we have u, and then we have du, and then we have our v and our dv. We can note that du and dv are mostly the same. Okay? Alright. Now, to choose the parameter u, we generally want it to be what's inside the integral, excluding the infinitesimal. So, we will set our u to be ln x. And the derivative of ln of x is simply 1 over x. And we just cross multiply to put the dx over here, which is the same as our dv. Our dv will be dx. Alright? And the integral of dx in the x world would be x. And that is our v. Alright? So now that we have our parameters, we can solve for this integral. So, the integral of ln x dx is equal to our u ln of x times v, which is x, minus the integral of v, which is x, times du, which is 1 over x dx. Okay? And we can just cancel this x quite nicely, so that we are left with the integral of 1 dx. And the integral of 1 dx is simply x. Okay? So our answer would be x ln of x minus x. And of course, don't forget the vitamin C. Do not forget the plus C. So that is the basic concept of integration by parts. And actually, there is a method in choosing the parameters, and that is the LIATE method. And this is something that goes on like this. So we have LIATE, okay? And it basically stands for logarithmic inverse algebraic trigonometric and exponential. Okay? So, what is this method? So basically, if we look from the bottom going up to top, we generally want to differentiate what's on the bottom first. So if you have an exponential function in a product, you generally want to differentiate that, since it is much easier. And then if you have, let's say, a trigonometric function and an algebraic function, you generally want to differentiate the trigonometric function over the algebraic function, since that is much easier. All right? Even though we have the commutative property of product, it is a useful method to know. Okay? Now, let's move on. So another variation of the integration by parts, and this is actually what I would like to advocate for most students taking calculus to use, and this is the DI method. Okay? So basically the DI method, or the tabular method, is a much simpler version of the usual integration by parts, since you do not have to repeat this all over again. So let me explain. Okay, we have the same integral from earlier, but now we are using the DI method. So how it works is that we set a parameter to be differentiated and one to be integrated. You can experiment with this, since we do not really want to use the LIATE method here. Okay, and then we set our plus and minus signs. I will explain that further on as we move on with more examples. Okay, so let us differentiate ln x, and we will integrate dx. Okay, the derivative of ln x is of course 1 over x, and the integral of dx is simply x. Now, how does this work? So, we generally want to find the product of the diagonals. And then, when we see the last row, we want to find the integral of this. The product of this, rather. We will find the integral of the product of these two parameters right here. So, let's go up here. The product of ln x and x is simply x ln of x. Okay? Now we subtract that. We subtract that to the integral of the product of this. Okay, let's put it here again. X times 1 over x dx. Okay? And again, this simply cancels, and we are left with the integral of 1 dx. And the integral of 1 dx is x. So our answer will be x ln of x minus x plus c. And as we can see, this is the same answer as when we did the integration by parts. Okay, so this is the DI method. And it has some stops actually when you are going to stop integrating or differentiating. And we have some examples to accommodate for that. Okay? Okay, now we have the integral of x squared sine 3x dx. Okay, so we will use the DI method. And don't forget your plus and minus signs, that is important. Now, let us differentiate x squared, and we will integrate sine of 3x. Okay? Now, the derivative of x squared is 2x, and then the derivative of 2x is 2, and the derivative of any constant is 0. Now we integrate sine 3x. So just for the sake of it, let us integrate it manually for now. So we have the integral of sine of 3x, and we can use a nice u sub here. So we can let u to be 3x, and so that du would be 3 dx, and finally our dx would be du over 3, or 1/3 du. So we have the integral of sine of u du. And let's put the 1/3 over here. Yeah. Now the integral of sine is negative cosine. And when we multiply that by 1/3, we're left with 1/3 of negative 1/3 of cosine. Our u is 3x plus c. Okay? 1/3 cosine of 3x plus c. And actually, you can see a pattern right here. And it is just when you keep integrating this, you just integrate whatever is in here and then multiply the bottom by 3. That is the algorithmic computation of this integral. So then the integral of this function would be negative 1/9 sine x. Sine of 3x rather. Okay, let's actually omit the plus c here. So since the integral of cosine x is negative sine x, we just copy the parameter and multiply the denominator by 3. Okay, so since this is the parameter, and then multiplying this by 3 and finding the integral of sine, the integral of negative sine is positive cosine. All right, so we have 1/27 cosine of 3x. Now we can multiply the diagonals, and you notice that the derivative is already 0, so whatever comes after this would be 0, since multiplying anything by 0 is always 0. So even if we keep integrating this, the derivative of this is 0. There's nothing to be continued. All right, so this is where we reach our first stop. All right, our first stop is that we have 0 in the D column. All right, that is our first stop. Okay, when we reach 0 in the D column, we can stop, and then we just find the product of this. Okay, now we just multiply. Okay, so multiplying positive x squared times negative 1/3 cosine of 3x, we will have negative 1/3 x squared cosine of 3x. Okay, and multiplying negative 2x times negative 1/9 sine 3x will yield you positive 2/9x, right? 2/9x sine 3x. And when you multiply positive 2 times 1/27 cosine of 3x, of course, you will have a positive answer. 2/27 cosine of 3x. And don't forget the plus c. So this is our answer, right? See how easy that is. All right, you can actually test it using the usual integration by parts, the LIATE method and all that, you can try that. But this is the answer. And the first step. Remember the first step? 0 in the D column. Okay? Now we move on to another integral. We have the integral of x to the fourth power ln x dx. Okay? Now, again, we will set our parameters. So we have the d and the I. And don't forget your plus minus signs. Okay? Now, what if we chose to integrate ln x? Actually, we don't really want that, since to integrate ln of x, we have to do another integration by parts. So actually, we can differentiate that. Right? And then we shall integrate x to the fourth power. Okay? Let's compute this in our head. So the derivative of ln of x is 1 over x. The integral of x to the fourth power using the power formula is 1/5 x to the fifth power. Alright? And what have you noticed? If we keep differentiating this will approach basically 0. Alright? This will approach 0. And if we keep integrating this will basically approach infinity. So that means the processes will never end. Therefore, if it is a sum of the infinite products. So the second step is right here. That is when we can integrate the product of a row. It is the same as we did with the ln x. Right here. Okay? So this is the second step. Second step. Product of a row. Alright? This is our second step. Okay? Now, again, we multiply that. So the first part of the answer would be, hold on, let me check. Alright, so we have 1 over 5 x to the 5th power ln x minus the integral of 1 over x times 1 over 5 x to the 5th power dx. And we noticed that these x's nicely cancel, and we can reduce the power from 5 to 4. So this is the same as 1 over 5 x to the 4th power, right? Okay, and the integral of that 1 over 5 x to the 4th power would be 1 over 25 x to the 5th power, since, okay, let's just compute it manually so we don't get confused. 5x to the 4th power. Okay, so we add 1 to this power, and then we multiply this by 5 by whatever is in here. Alright, so that's, hence we have the answer. And don't forget the plus c. Okay. All right. Now, so that is our second step. Now we actually have a third step, and we can find this in our third integral. We have the integral of e to the x sine x dx. Okay. Now we choose our parameters to be differentiated and integrated. So we put our di and our plus minus plus minus. Okay. So let us differentiate e to the x, and we will integrate sine x. The derivative of e to the x is always e to the x. The integral of sine x is negative cosine x. The integral of negative cosine x is negative sine x. And the integral of negative sine x is positive cosine x. Okay. Now, what have you noticed with the table? The third row repeated the first row, as you can see. So this is where our third step is. Third step. A row repeats. All right, that is our third step. Now we just have to multiply these. Okay, and then we actually have to stop here. So we do not include the following, since it already repeated. We do not have to include whatever in the bottom. Okay. All right. So that would be equal to positive e to the x times negative cosine x would be negative e to the x cosine x, right? Plus the product of negative e to the x multiplied to negative sine x would be positive e to the x sine x. All right. And then we subtract it to the integral of this. So it's the same as the second step. We have to integrate the last row, the product of the last row, rather. But we can do something nice here. So we put the integral of e to the x sine x dx. Since it repeated, we can add this integral to both sides. So we can add the x sine x dx as well as to this side. Okay, so that this will nicely cancel each other out. So now we are left with 2 integral of e to the x sine x dx is equal to negative e to the x cosine x plus e to the x sine x. Okay, and to negate the 2, we shall have to multiply everything by 1/2. So that the 2's will cancel. Okay. So finally, the integral of e to the x sine x dx is equal to negative 1/2 e to the x cosine x plus 1/2 e to the x sine x. And don't forget to plus c. And we're done. And that is basically the concept of the DI method. And as a student myself, I recommend that you use this for most of your integrating journey. And that basically wraps up our video for today. So if you like the content, be sure to leave a like and share this to your friends so that they can learn more about calculus, and for me to get motivated more about making videos like this. So that's it. Thank you for tuning in until the end. Bye bye.